Hi, in this video, we are going to see how to do a quick stack implementation. In the previous video, we talked about different applications for arrays. Remember, we talked about adding at the end and removing from the front and, last in, first out, first in, first out, different types of data structures that we can mimic with an array. So I'm going to show you real quick. You can take this and do many different things with it. There is no limit. You just need the time to be able to think about, okay, what can I do with this? What kind of applications can I come up with? Just come up with anything that you can practice to write an algorithm with. So we are going to do a push, pop, and print data structure where every time I push something onto the stack, I'm going to take away all this. So we start from scratch. So count is sitting at 0. There are no elements in my list. My array is called list, or my stack is called list. You can call it stack if you want. Every time the user pushes something, it's going to get added here, wherever count is. And initially, when there's nothing in your list, count is at 0. Then count goes here. The minute I add something, count goes to the next one. Then again, if the user says push, I'm going to push it here, and count goes here, and so on and so forth. So every time the user, and we're going to do a quick menu-driven program. So the user is given the option to push, pop, and print. And the user says push. You say, okay, give me a number. The user says 5, and you put it there, and you increment count. Well, the user says push again. So this is how your menu is going to work. Then you say, give me a number. And the user says 12. It's going to go there. User says push again. Okay, you say 6. 6 goes there. And count has now moved on to here. Then you say print. And so your stack is going to print 5, 12, 6. Then the user says pop. Then you say, give me a number. And they say 6. Then your code should put a 0 here and move count down here, because now there are 6 has been popped off. There are only 2 elements. Then they say pop again. Then they say 5. You say, give me a number. They say 5. Now your program should pop everything off, put it to 0, and set count here. Then they say pop again. So here's my program. Continue. There's no room there. Pop. And then you're going to say, well, no more numbers in your list to pop. They're going to say push. They say, okay, give me a number. 10. 10 goes here. Count is here. You get the idea. That's kind of how this program is going to work. So let's see how to implement the push. Okay. So let me just start over. Okay, here's my array. My count is empty. Every time they call, my array is empty, my count is here. Every time they call push, it's easy, right? You just have to say list of count plus plus equals the number they enter every time they call push. That's all that goes. So the number goes in, count gets incremented. This is push. Now pop, what do we do with pop? So let's say we have a bunch of numbers in the list, and let's have a few numbers, otherwise it's hard to pop. 4, 20. Okay, so let's say count is not here. Let's say count is here at 5. And let's say the user says pop, and you say, okay, give me a number. And the user says 9. So here is 9. You're going to go through your list. Now you know how to find the number. You compare and you find the number. And, I equals 0, I less than count, blah, blah, blah. You can say if list of I, you know how to compare. Now we've done that. Equals num, which is the number that they enter. Then you're going to say, okay, index or del pos or whatever you want to call it. Let's call it pos. Pos equals I. Okay, and you break. We've done this before. Okay, we break. We are out of that loop now. Okay, we have found the position, and then you know how to say if the number is not there. So pos marks our position as to what we want to delete. Here is pos. Okay, so now how are we going to say I want all of these things until count set to 0? So start another loop, and you can use I don't care, for I equals pos, I less than count, I plus plus. set everything to 0. List of I equals 0. All the elements should be set to 0. Everything is set to 0. Count needs to come here. That's the new position. So count equals pause. That's it. We have popped off everything. Count has moved over here. Now I only have 2 elements in the list, and pop is done. Right? That's it. So there's really not much shifting. Sometimes you don't have to do much shifting. It all depends on the algorithm. So if I were to write code for this, I started something here. The stack implementation. I have push, pop, and we're going to do a quick menu here. We're going to do a do while. You're going to ask the user, cout, and you can make a function for this by saying enter, pick an option from below, pick an option, and you can just do it here. Push to pop, 3 print, and 4 quit. And you can come up with a nicer one if you want to, but this is good for right now. Okay, cin into number option. Let's declare a variable option for that. Okay, and then you do while option, and then you do, you know how to do all your data validation and all that stuff by now. While option not equal to 4. Okay, here's where you're going to do your switch case. Switch option case 1. If I can spell switch. Okay, case 1. You're going to call push, and you need to send the list and count to it. Break. Case 2. You're going to call pop. You're going to send list and count to it. You're going to break. Case 3. Oops. Print. You're going to call print. You're going to send list and count to it. That's it. We always send list and count to it. List is the list, and count is what keeps track of the number of elements in the array. Somehow we need to keep track of that. So count always goes with it. Default invalid option. Please try again, because we are in a loop. And we just put this back in here at the end, outside the switch. We don't have to do that inside the switch. Outside, there's the switch is done. Do that there. So, and you could put this whole thing inside a function. So you read the option one time. While it's not equal to 4, you switch it. If it is 1, you push. If it is 2, you pop. If it is 3, you print. If it is anything other than that, you tell them, nope, invalid. And then when the switch is done, it's going to come here. And it could be invalid. Whatever it is, it's going to come and repeat this, right? And we just keep doing that until option is not equal to 4. When it's equal to 4, it's going to come here and you're going to be done. And you can do your thank you message and stuff. Okay, what happens when we push? We talked about this, right? When they say push, we need to ask them to enter a number. So let's declare a local variable num equals 0. You tell them cout, okay, enter the number to push. To push onto your stack. That's really what that is. Okay, and cin, and you should use that readInt function that we have written somewhere in before. You to do data validation, you read it and then make sure count is less than cap, because even though you have a stack, the stack will run out of room because we have an array. Okay, and we said this list of count plus plus, that's it, equals num. This is all we need to do. And count comes in by reference, so count is going to get incremented and it's going to go back automatically changed. So every time they push, you'd come here and say enter the number, read the number, and just add the number to the list. Okay, that's it. Now pop, make sure you have function prototypes. Do you know how to do functions? Now you must have prototypes. Don't write functions without prototypes. The other thing you must have is you must have function comments like I have shown in some of the other programs. My style guide has examples. You must have comments that says the name of the function, the parameters it takes, and so just look at the style guide for sure. Okay, when they say pop, I'm looking at my algorithm. We said we are first going to do the same thing. We're going to ask them what number do they want to pop, unless you always want to pop the top number, which you can, but then that's just one number at a time. So if they want to do multiple numbers, or if they want to pick the number, then you are going to do this. Then you're going to go and find the number, I equals 0, I less than count, I plus plus. If list of I is equal to num, then you're going to mark pos equals I, and you're going to, so I need my curly brackets here. I'll declare pos up there, and you're going to break, and you declare pos equals 0. And we know this, we've done this before. I'm going to have my I up there because I need to know. No need for that. Okay, so when I come out of my if statement or my for, when I break out of it, I need to know if my number was there. If this I is equal to, or if I is if I is equal to count, which means if we went all the way, then we know that we didn't find the number not found. Cout number not found. Okay, else we have to do one more. We'll do that in a minute. Else, that means we found the number and pos is equal to I. We're going to go through a for loop for, and what do we say? Let's say j, because we are using I. J equals pos, j less than count, j plus plus. We are going to set everything of j, don't use I, j to 0, and we are going to set count equals, not like that, equals pos. We said that, right, in our algorithm. And all of that should be in the else. That finishes the else. Okay, that matches the else. Okay, let's look through this now. We read a number, pop. That didn't make sense. Okay, we read a number to pop. We check to see if the number is there in the list. We mark the position, we break, we come here. If I equals count, that means the number is not there because I went all the way to count and we haven't found the number. If not, the number was found. We start j at that pos, we go till count, we set everything to 0, we move count all the way to pos, and we are done. Now what happens if the list is empty? So before you even do anything here, you should check if you can do this. Count is 0, right? If not count, that says if count is 0, not count will be 1 and the condition will be true. So you have to say if not count, simply tell them list stack is empty. That means there's nothing in count. And you can say nothing to pop. And line. And we're going to have an empty return, a blank return, which will just return from the function, which is what we want. It's a void function. Don't return anything. Just return, we'll say control comes back to wherever it was called from. And we're calling this from main. So we go to pop, and if the list is empty, it should simply come back. If the list is not empty, then not count will become false, because if count is anything greater than 0, not count will be false. If count is 1, not count will be false. If count is 5, not count will be false. So then we'd come over here. We would never go into this if. We would come here and start trying to pop numbers. Okay? And print just prints it. And in print, here's a teaching moment. In print, Print is a function that does not change the list. Notice push and pop actually changes the list and count. List gets stacks, number gets added to the stack, number gets popped off the stack. Count gets incremented, count gets decremented. Whereas a print, nothing changes. So count is passed by value, and the list, which is always passed by a reference, has a constant in front of it, saying don't change the list in the print statement. You cannot change the list. If you try to put a value in the list, it will give you an error message saying, hey, your list is constant, you cannot change it. I can use it to print it. I can use it to search. I can use it in different ways. I cannot change it. Okay, so let's run it and see what we get. Okay, so let's first try an invalid option. Okay, that works. So let's try to pop something. Oh, it says stack is empty, nothing to pop, which is what it should do. Okay, how about number 1? Okay, 5, 3, 4. Okay, I want to print 3. 5, 3, 4. That's how I add it, right? Okay, let's push a couple more. 12, push 23. Okay, print. Okay, now let's say that way I have more numbers. I want to pop. So if I pop 4, I should only have 5 and 3 in my list. Print. So there you go. You can push 23, push 45, push 9, print. Okay, now pop, which is number 2, pop 45, print. Okay, and then quit. Let's see if quit works. There we go. Okay, so think about what you are trying to do. Read the program question, whether it's whatever it is, read the problem statement carefully and apply what you have learned in different ways. Don't be stuck in a box. Okay, I'll see you in the next video.